Welcome back to the channel. Let's see today's daily challenge on Leetcode and we will try to solve it together. So today's challenge is a moderate problem. It might be confusing to some people who are not that much aware of this pattern, but let's see the question and try to understand. The problem statement is really simple: maximum subarray sum with length divisible by k. So I hope you already know how to calculate the maximum subarray sum, and you need to find only those sums which have length divisible by k. So you will be given an array of integers nums and an integer k. You need to return the maximum sum of the subarray of nums such that the size of the subarray is divisible by k. Okay, so you need to have only those subarrays which are divisible by k. So you can see these kinds of example, even negative numbers can be there. So for k equals to 4, you select the bottommost 4 numbers, because the whichever number you are selecting has to be a multiple of 4, right? So this is the only way, and minus 10 is the best answer, that is the maximum possible answer. Similarly for this, you see, for k equals to 2, if you try to select these two numbers, it will be 3. If you try to select these two numbers, I hope you already know that subarray means they must be contiguous. Okay, the elements must be contiguously present. Okay, so for 4 and minus 3 it will be 1. Okay, but if you consider this whole subarray which is of length 4, and 4 is divisible by 2 definitely, right? So 1 2 minus 3 4, this whole thing of length 4 will be divisible by 2, and if you add all of them, 1 plus 2 plus minus 3 plus 4, you will get a simple 4. Okay, and the maximum subarray sum is 4, therefore that is what you need to output. So how exactly will you calculate this? So let's try to understand. The main thing which you need to remember here is that uh, subarray size should be divisible by k. What does it mean? It should be divisible by k means it should be a multiple of k. So let's say if k equals to 5, what are the subarray sizes you can have? You can have 5, 10, 15 and so on. These are the subarray sizes which you can have. So whenever you talk of the method, whenever you see the subarray word in the question, you already know that there is an array and some portion of the array we are talking about. Let's say I will take from j to I, not I to j, you will realize why. Okay, so this portion of the array we are talking about, and it is worth trying. If you cannot solve it by some other methods, it is worth trying to solve it by prefix method. Why? Because you know that I hope you already know what a prefix array means. That I am not explaining, because yeah, I am assuming that much you know. What does prefix array means? Prefix sum means basically you sum up all the numbers. So 5, 6, 8, 12, if this is an array, then the prefix array will be 5, 5 plus 6, 11, 11 plus 8, 19, and it's 31. I hope you know this. And if you want to, let's say, calculate this plus this, you can subtract. Let's say this j and I you want to calculate, then you have to subtract this 19 I, array of I which is 19, minus of array of j minus 1 which is 5, right? So 19 minus 5 if you do, you will get 14, which you would have also done by adding these two numbers. So the subarray sum you can calculate in this way. I hope you do know this. Okay, if you do not know, I just explained you right now. So yeah, whenever the subarray sum word is told, you definitely know that my answer subarray sum can be calculated by something like this. If this is the prefix array, prefix of I minus of prefix of j minus 1. Now when you want to iterate through I and j, you know that in this problem there is I and j, you cannot iterate through two variables, right? Since it is of O of n only you need to do, or O of n log n, you cannot do n square. So you cannot you cannot afford to have two variables iterating. Okay, so one variable you try to fix and you try to see what are the possible values of other variables. Okay, so what I want to say is that let's say when what do I want from this whole thing? We want this answer to be maximum, this subarray sum. This is giving me a random subarray sum from j to I, right? The subarray j to I, it is giving me a random subarray j to I, and if it is giving me a sum, but I need to maximize this. So one way can be you choose the minimize, then you choose to minimize this whole value. Okay, you choose to minimize this whole value while iterating through all possible I. So let's say for all I, you iterate and see that how you can minimize this particular term, then only you will end up in maximizing this answer, right? I hope that much intuition you know. See, whenever you get stuck in these kinds of problems, you just write everything you know. What is the subarray sum, what is prefix, and you try to make some pattern out of it, and you will definitely get it. Okay, so let's now consider our array. So yeah, let's say I have a large array. Okay, I have a large array like this, and one thing you know that whenever we have, let's say we are considering subarray j to I. Now this whole length should be, as I told you, I am assuming k equals to 5 right now. So it should be a multiple of k or multiple of 5. So this length should be 5, or this length should be 10, or this length should be 15, something like that. Okay, so it must be groups of k. So it definitely makes sense to arrange your indices in groups of k. So what do I want to tell you basically? Arrange indices in groups of k. Okay, how will this help exactly? So let's say what I am trying to do right now is this is the index 0, this is 1, this is 2, this is 3, this is 4, this is index 5, but I have got 5 numbers, I have got 5 indices so far. But so I want, in order to make a different group from the rest of this, I will try to write it in this way: 1, 2, 3. This is just a pattern. Okay, and you see again I want to do like this. Okay, I hope you do understand what I am trying to do, right? So so what I did just now, I arranged in groups of 5. So in groups of k, as I am arranging, I did every index I modulo k. I am storing them. Okay, so how does this exactly help me? You are telling that, hey, you are directly telling me, hey, you transform all your indices, but how will we know that it is helping me? So as I told you that I am considering the subarray j to I. Okay, and I just now told you that j must be in multiples of I. So let's say you are at I is at this point. Okay, so you are willing to consider the length 5. You see 1, 2, 3, 4, 5. You consider this whole length, right? And in order to have the prefix sum, I hope let's assume that this whole array is nothing but the prefix array, because this is only what we are concerned about right now, right? We need to maximize this answer, and the prefix we need to minimize, prefix of j minus 1. So you see I took 5 length over here, so j is here. Okay, j is at this point. So what is j minus 1? It is at this point. What if I wanted to consider 10 length? So again 5 is taken here, then it is 6, 7, 8, 9, 10. Again now, right now j is over here. What is j minus 1? This is again, you see, it is 2. So one thing you observe that you need to subtract this j minus 1, right? So if I is at index 2, then j minus 1 is also at index 2. Again the next j minus 1 is also at index 2, and if you subtracting j minus 1 from I prefix, you are automatically selecting indices which are length, I mean selecting arrays, sub arrays which are length of the multiples of 5. Okay, so this is 5, this is 10, and maybe 15 also you will get if the array was larger. So I hope you do get something right now. So what do I want right now? Okay, when I am at index 5, when I am at index this I, okay, when I am at index I, I need this index, so my length I minus 5, this whole length from I to I minus 5, this length subarray I want. Okay, So I want to subtract, this must be my j, that much is clear, but I want the minimum of all of them, right? So minimum of whose, you see, this value, this value, this value, whatever was there. So let's say at a distance of 5, at a distance of 10, at a distance of 15, all of these I want the minimum among all of them, right? I am currently at I want something at j minus 1. Okay, so I'm currently at I. So yeah, let me just remove this once. Yeah, so what I was telling is that I am currently at I. I want to subtract the prefix of j minus 1 from me. I want to minimize this prefix of j minus 1. I also know that if I lies at 2, then j minus 1 also lies at 2 only, the same thing. So basically it lies at I modulo k. 2 is nothing but I modulo k, right? The actual index which was there, I did modulo k of all the indices. So I modulo k is also equal to j minus 1 modulo k. So basically this value of I modulo k, j minus 1 lies in all of them, okay? It lies in all of them, and you need to find the minimum of all of them, okay? So this one, and this one, the minimum of all of them. So okay, let's, if this is a, this is b, this is c, you want the minimum of a, b, c, okay? That's what. So you can calculate, you have the prefix array with you right now, okay? I hope you do also get why I'm doing the minimum. Don't get confused in between. I'm doing minimum because j minus 1 I need to minimize in order to maximize this whole difference. Okay, so that's what I'm doing. And you see, to keep a track, we can keep us running some minimum. Okay, so let's, why not have a separate array of length only 5, that is of length only k. So 0, 1, 2, 3, 4, and we will store the minimum value. So for 2, so when we are at a, let's say this is also 2, right? Because that will be 4, 3, and this is also 2, this was also 2, this was also 2. So at index 2, whenever I will get a, I will store this. Then again, when while iterating, when I will get b, I will store the minimum of a comma b. Then at again, when I will at this index, I will be at this index, I will store the minimum of a comma b comma c. So I am computing all the previous running in prefix minimum, okay? Computing all previous prefix sum minimum. So yeah, this array you can call it as minimum prefix array, minimum prefix sum also you can tell, and this is the one which will help me in making sure that my sub arrays are of length only of multiples of 5, or that is only of multiples of k. And yeah, in that way I will just keep on having and just maximize this value, okay? So yeah, I hope this approach is now clear to you. You should be able to do this on your own also. There is some edge cases also over here. So let's see, let's try to have first of all we have this index n nums dot size, okay? Instead of prefix array, let's say we have prefix sum only, okay? Prefix variable, because I do not need to do anything with the prefix array, I just need to calculate it once. So I will have the prefix variable instead of the prefix array, okay? So it will just have give me all of the values of the sums, okay? So you also have an answer which is nothing but the maximum subarray sum, so which is divisible by k. And what else do you need? You see, you need a vector. This vector at least you need, because you are calculating the running minimum among all the prefix. So prefix sum minimum you need to have, okay? So vector of long, I will call it prefix sum minimum, okay? And this will be of k, and see, answer I need to maximize, right? So I will have int min. So since long is here over, I will just tell long main, okay? Or I can do 1e minus 1e 18 also, okay? Whatever be the case. And this is the minimum value which we are calculating, so I should initialize this by the maximum value 1e18, okay? So yeah, I am doing 1e18. I will prefer that you do long max, okay? If there is an error with 1e18, I will definitely go ahead with long max again, but mostly this is a very large value, okay? So yeah, so I hope you do understand. Answer we need to maximize, and these are storing the prefix sums in the minimum values. Okay, so for integer of I n I plus plus, one thing which we can do is that at every step we can do this I modulo k, okay, and store it in the prefix sum. So prefix sum minimum of I modulo k will be equal to minimum among prefix sum minimum of I modulo k again, right, and with what we will do the minimum, we will do the minimum with prefix, right. The minimum we are calculating the prefix, right, so with prefix of I. So basically this is the thing which we are doing when we are at index I, okay, when we are at this index I, I modulo k, all the values of I modulo k we are minimizing, okay. I hope that is clear, at least this much, there should be no issues. And after this what I can do, definitely I can update the prefix sum, okay. So prefix plus equals to I hope this much you can understand easily, right, there should be no doubt here also. And you can answer maximize your answer. What is your answer? This is nothing but the maximum subarray sum. So that is nothing but your answer comma what was the formula which we derived, prefix of I minus prefix of j minus 1, okay. So prefix of I is nothing but this prefix only, and what is the prefix of j minus 1? It is these minimum prefixes, so it can be found in this array only. So which is nothing but prefix sum min I module, okay. So prefix sum min I module, okay. Okay, I hope you do understand what I am trying to do. And yeah, I guess that is all. If you try to return let's say the answer, let's try to run it and check if it works or it does have some edge cases still. Yeah, so prefix sum minimum, so I use a small p everywhere, right? So yeah, so pref of I, not pref of I, pref of I is nothing but pref only, because a prefix is not an array, it is a simple number, right? So yeah, so you see you are calculating this. Now there is something which is there, is that you are not considering those subarrays which are starting at index 0, because if you see, what did you initialize this prefix sum minimum by? 118, right? And but what is the prefix? Why I want to tell you that what is the prefix till index number -1. See, till index number -1 the prefix is 0, right? And when we are including something like, so let's say when we are calculating something like prefix of I minus prefix of j minus 1, and when I am calculating something like this, what if j is 0? So you are considering the index j to I, right? J can be 0, that is the first index, and j minus 1 at that time prefix we cannot calculate. So whenever this will happen, it will try to, I mean, it will not find anything. So j minus 1, when it will do a modulo of k, okay, it will get this only, right? So this element, if you initialize by 0, that will make sure that your -1 index is enabled, okay. So what we do here, try to do, is that prefix sum minimum of k minus 1, just the last value I just initialized to 0, it just helps us tell that the prefix till -1 was 0, right? So you take care of that, so that you do not ignore those subarrays which start at index the first index, which start at the first index, okay. So if I try to run now, will it work? Let's see if it does work, or still we have to do something. Just wrote the wrong variable over here. So yeah, you see it does give you the accepted solution, and if you try to submit it, I hope it should work just fine. If these are correct at least. So yeah, it just works fine, and you also see you have a decent runtime as well as memory complexity. So yeah, I hope you do understand the solution. The coding portion was very simple. It's a simple 10 lines of code, right? But yeah, understanding this pattern is important. This idea is important, that whenever you need to jump 5 indices, it is always better to keep a modulo of all those indices in some different array altogether, okay, in some different small array, okay. So yeah, I hope this idea at least clicked to you, and you can use them in other problems also. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.